All right. So we're going to do chapter 3 today. So I'm going to start from 3.1, which is the definitions of a momentum and also impulse. So we're going to see how to use the equations for momentum and impulse. Now momentum, we know that P is equals to mv. Impulse J is equals to ft. So we're going to see how to apply these two equations in the first exercise. So how do we know when to use which equations? It's very simple. Questions will tell you. So a 750 kg car has a speed of 10 meter per second. So what is the momentum? Now question asking for momentum, it gives you what? If you look at the questions, always make it a habit to write down the information first. Okay, it won't take a lot of time in your exam. It might just take a few seconds. So you just rewrite it. So you have m equals to 750 kg, and then you have a speed which is v equals to 10 meter per second, right? So when you have these two informations, then you can apply p equals to mv easily. All right, so you applied it until you get the answer. So the answer is a 7,500 kg ms negative 1. Okay, 7,500 kg ms negative 1. So you do the substitutions, yeah? So I'm going to skip the substitutions part. So questions 2. A skater of mass 80 kg. So you have a mass 80 kg. Initially at rest. Aha. So you are given the terms at rest again. And then it's speed up to a final speed of 10 meter per second along a straight line towards the east direction. So find the momentum of the skater while it is at rest. So initially you have m equals to 80 kg. The terms at rest, it tells us u is equals to 0 ms negative 1. Now the reason I use u because the question say initially. All right. So when you combine these two again, you have a p initial equals to mu, which is equals to the substitution, and then equals to 0 kg ms negative 1. Find the momentum while it is traveling at its final speed. So you have a case where it tells you the object, the skater, is moving with two different speed, one initial and one final. So now final, what am I going to do? Again, m is equals to 80 kg. And then v now given is equals to 10 meter per second. So when you combine it, you have p final equals to mv. Okay, and then you have 800 kg ms negative 1. So find the change. Now, when the question mentions the terms change in momentum. So what does it mean? It means it wants final minus initial. So delta P is equals to P final minus P initial. All right. So equals to 800 minus 0, which is equals to 800 kg ms negative 1. So remember, change, it should be in a final minus initial. You don't use initial minus final. All right, so when you have change, final minus initial. So next we are going to look at the next question. So this question is still very simple. You just follows the informations given. Okay, you follows the informations at rest, which is the initial, and then at a final speed. Okay, so which is a v. Right, so next. A system is made up of two objects moving in a straight line. Now you have two objects, means you have two set of information. So I would like to call it, now in this case, whenever you have a case where it involves two objects, you give it a name first. Okay, you give it a name. So I'm going to call it object 1 and object 2. So one object, I'm going to call it object number 1 of mass move to the right at a speed of 10 meter per second. So now the keywords, the question gives you direction. When you have two objects and they have two directions, so the first object is moving to the right and the second object is moving to the left at a speed of 12 meter per second. determines the total momentum of the system. So these are the keywords in a question. So first one, object one, I'm going to call it M1. Okay, so M1, it is equals to 1.5 kg. And then it's moving to the right at a speed. To the right, I'm going to take it as a positive direction. So my V1 is equals to positive 10 meter per second. The other object, well, I would like to call it object 2. Now, you can call it object A or object B. It's up to you. So object 2, it comes with M2 equals to 2 kg. And then my V2 is equals to, now, question say negative. Negative means negative directions. Means it mentions to the left. To the left means negative direction. So negative 12 meter per second. So this is what we have now. And if you look at the question's asking for what? Question asking for total momentum. Now, just now is a change in momentum. Make sure you read the questions carefully. Okay? Question sometimes will mention change, sometimes will mention total. Change means final minus initial. Total means you're going to add them up. All right, so it's up to you whether you want to calculate them separately or you want to make it in one equation. So I'm just going to make it in one equation. So total summation P equals to P1 plus P2, which is then equals to M1 V1 plus M2 V2. Now, when it comes to substitution, because you have a negative value, make sure to substitute the negative in your equations. So it is equals to 1.5 times 10 plus 2 times negative 12. Therefore, the final answer is now negative 9 kg ms negative 1. Okay, so it means when these two objects collide with each other, then what is going to happen? So they will move. Okay, they will move with total momentum, which is a negative 9 kg ms negative 1. Now, this one, okay, this one you have a negative value. So negative value, I would encourage my students to write one more sentence. This negative, it represents direction. All right. Now, sometimes some students, they like to put a negative at the back. For me, that is fine. Okay, I think that is correct. But some lecturer, they like to argue. They say now you have negative and you say to the left. So it's a contradict because negative in a vector already represent direction. Okay, so in that case, to avoid all the argument, I would encourage my students to rewrite it in a statement form. So it is 9 kg ms negative 1 to the left. Okay, to the left. So you just rewrite one more sentence to avoid all the argument, okay? Because some lecturers, they like to say that negative and to the left means your object is now in the positive direction, something like that. Okay, so to avoid all those argument, okay, all those unnecessary argument, I would encourage you to rewrite it in a sentence. Okay, rewrite in a sentence. So you calculate, you got a negative value, and remember, because now you're looking at momentum. Momentum is a vector. Okay, momentum. So what we know about momentum, it is a vector. So what does it mean by a vector? You need to have a value, magnitude, and also direction. All right. So even though the negative represents the directions already, but you need to rewrite it in a sentence. Okay, you need to change it into a sentence. So you just write one more sentence. Whenever you have a negative vector, you rewrite it in a sentence form. You write one more sentence. Okay, to show that you know the object is now moving to the left with a magnitude 9 kg per meter per second. Now, this is also a way to prevent you from doing careless mistake. Why? Because sometimes questions will just ask for the magnitude of the momentum. If you leave your answer in a negative form, then you're going to get 0 mark. Because magnitude is a value without negative sign. All right? So I would rather you spend another like 2 or 3 seconds rewrite your answer in this sentence form rather than you just leave it in the negative value. Okay, because negative value, it can cause a lot of argument. And then if the question is asking for magnitude, then you're going to get 0 mark. Okay, you're going to get a 0 mark for the answer because magnitude must be a positive value. Okay, it must be in a 9 meter per second, 9 kg meter per second. All right, so I give you 1 minute to write it down and then to jot down the things that I told you just now. Okay, the reasons why I asked you to put a negative sign, and then what happened if the question asks you to write the magnitude, to calculate the magnitude of the system, the magnitude of the momentum of the system. Okay, so 1 minute before we proceed to a more complicated question. All right. So next. Next, if you look at this diagram, obviously now this is a two-dimensional questions. So figure shows two objects, A and B, moving on the XY plane. The masses of A and B, they are 1.5 kg and 2 kg respectively. So your MA given is 1.5 kg. And then MB given is a 2 kg. Now determine the magnitude and the directions of the resultant momentum of two objects. How are we going to calculate it? Now we have object moving in two different directions. We cannot simply add them up. Right, resultant, it wants to calculate the total. It wants to calculate the combinations of two objects. But now you cannot simply add them up. Why? Because now they are moving towards different direction. So what can you do? If you recall what have we learned in the chapter 1, now you have two vector. Vector PA, okay, and then a vector PB. So what you can do, now let me write them in a coordinate form. Okay, I'm going to change it a little bit so that you can see what happened. So this is my X, this is my Y plane. What am I going to do? Now I have two vector moving towards a different direction. So I'm going to take the arrow one by one into the XY plane. So let's begin from A. So this vector A, this arrow, okay, now I color it in the blue color. I'm going to move this blue color arrow to my new XY plane and let it start from origin. So this is my PA. And then this is my 30-degree angle. Okay, so PA moving with 3 meter per second. So this is your MAV. Okay, this V is a resultant V. So what are you going to do next? After that, you're going to resolve the V. Okay, you're going to resolve the V. So the next vector, I'm going to color it a vector in green. Okay, B now is the green color. So what am I going to do? I'm going to take this vector, this whole vector, and put it in the XY plane. Okay, I'm putting it in this plane. So now I have this vector PB, which is equals to MBV. All right, now I have a complete coordinates. Okay, I have a complete XY plane, Cartesian coordinate, the vector. What am I going to do next? I'm going to do a table. All right, I'm going to do a table. And then, all right, X component, Y component, I have a PA, I have a PB. All right, I have PA, I have PB, and then I'm going to calculate the total P. Okay, so this is my table. This is total. Okay, this is total. So what am I going to do for the x component? Well, like I told you just now, I'm going to resolve the velocity. Okay, so if you're going to calculate PA along x component, so let's see, this is your PAX. So PAX is now equals to your MAV. Okay, now I'm going to add a subscript here. So VA along x component. So given VA equals to 3 meter per second. So now your job is to resolve VA into its x component. All right. So therefore, what am I going to put in the x column? So I have a M, which is a 1.5 kg. Okay. 1.5. So I'm just going to write it down 1.5 because M, you don't have to resolve it. Then I want to resolve the AX. So resolve AX, resolve velocity along X component. So I have 3 cos 30 degree. Okay, 3 cos 30 degree. So from here, you can get the value for PAX. So 1.5 times 3 cos 30 degree. So you see what is the answer. Okay, you see what is the answer. So if I'm not mistaken, let me see. The answer should be 3.9. Okay, you have a 3.9. So 3.9, 9.9 plus 3.9 kgms negative 1. That is your PAX. Okay, that is your PAX. And then your PAY. PAY, it is equals to MAVAY. So now you want to resolve V into Y component. So what am I going to do? So PAY is actually equals to 1.5, and then I'm going to resolve the velocity. So a 3 sine 30 degree, which is then equals to 2.25 kg ms negative 1. So both of them, they are positive because my PA is located in the first quadrant. Okay, so the key point here is to see whether you know how to resolve Vx or not. All right. So the key point is to resolve. So how am I going to calculate the PA along X component and PA along Y component? It all depends on your V. Okay, so you have a PAX and you have a PAY. So how do I know what is the value? How am I going to calculate PAX? I use VAX. So VA given 3 meter per second, then you just resolve it into X component, like what you have been doing in chapter 1. Okay, like what you have been doing in chapter 1. Then you just repeat the same thing for PB. Now PB, well, actually PB is easier. Okay, it's much easier compared to PA. PA, you need to resolve it because it's located between X and Y component. When it comes to PB, if you look at the diagram, okay, for instance, you know you don't have to resolve it. Why? Because it's lying on the X component. So straight away, Y component is equals to 0. And then X component is equals to 2 kg times the velocity, which is 5. So 5, therefore it is equals to 10 kg ms negative 1. Again, it is a positive value because you have a positive velocity. Okay, it is heading to the right. So now I have a VB, okay, which is equals to 5 meter per second. And this VB is equals to your VBX. All right, VB equals to VBX because now your object is lying on the X component. So now that you have the table, you want to calculate total. Okay, you want to calculate the total value. So how are we going to calculate the total value? As usual, you're just going to add them up. So you add X component, Y component, and Y component. So X component, now I have total PX. Okay, summation PX is now equals to 13.9 kg ms negative 1. and then total Py is just equals to 2.25 kg ms negative 1. Both of them, they are positive value. Okay, both of them, they are positive. Now that you have the total, you can then calculate P resultant. So P resultant is equals to square root summations px square plus summation py square. Okay, so you sub the value and eventually you are going to get a final answer, which is 14.08 kg ms negative 1. Now, once again, the question is asking for resultant momentum, which is a resultant vector. Therefore, you need to calculate its angle. So angle equals to tangent negative 1. Well, I like a modulus here. Summations py over summations px. Right? So I'm going to get tangent negative 1 and then a 2.25 over 13.9, which is then equals to 9.19 degree. Now, this is not your final answer yet. You need to describe it. So where is it? So you look at these two values. Now you have positive px, you have positive py. Positive means that it is located in the first quadrant. So first quadrant above positive x axis. Okay, so above positive x axis, that is your final answer. So this is a complete answer for questions 4, I think. Okay, the complete answer for questions 4. And this is how you solve it when you have a vector in 2D. Okay, you have a vector located in between x and y component. So now I give you 3 minutes. Okay, I give you 3. So you can complete it. Okay, you can write it down. So this is a complete solution. Okay, what did I do from the diagram given? So I change it into xy plane first. Okay, I change it into xy plane. So I move into this plane. So when it's in this plane, I then resolve it into x and y component. So how did I resolve it? Take notes, the part that I resolve is not the mass. The part that I resolve is the velocity. Okay, it's the velocity. Now, some students might ask me, can I calculate PA first before I resolve it? Of course you can. Okay, you can calculate PA, which is equals to 4.5, and then you resolve the P. Okay, so 4.5 cos 30 degree, 4.5 sine 30 degree. You're still going to get the same answer. All right, so this is an alternative method. So alternative method, you calculate PA and you calculate PB. All right, so PA equals to 4.5 kg ms negative 1. PB equals to 10 kg ms negative 1. Then you put it in the table. Okay, so in this case, what you are resolving the P. Okay, so the case that I showed you just now, I resolve V. So here you can straight away resolve P. It's still fine. Okay, you're still going to get the same answer. So PA, PB, PA, 4.5 cos 30 degree, and then 4.5 sine 30 degree, and then PB 10, and then this is 0. And then after that, as usual, you calculate the total. Then you can go back to the resultant. So total, you will get PX, and then you will get PY. All right. So I show you both method. It is up to you to choose which one is easier. Okay, which one is easier for you. Right. So I give you now it's 26 minutes. I give you until 8:30. All right. You write it down. You can write down both method, or you can write down the one that you think is easier only. Okay, so let's move to next question. Now, next questions will start the impulse. Okay, next question is an impulse questions. So we are done with momentum for now. Let's zoom it back. Okay. Okay. So questions 5. Questions 5. A 0.2 kg tennis ball strike the wall horizontally with a speed of 100 meter per second. It then bounces off with a speed of 70 meter per second in the opposite direction. So now you have the keywords in the opposite direction. So how am I going to solve this question? Now, before I solve the questions, I need a diagram. Okay, I need a diagram. I want to see what happened. So let's say this is a wall. So my object, which is a tennis ball, initially moving, now let's assume the initial direction is a positive direction. So it's moving with an initial velocity which is equals to 100 meter per second. All right. It then bounces off. So bounce off with a velocity. Now this is your V, your final velocity. Now because it's bounce off in the opposite direction, your V is a negative value. So negative 70 meter per second. Okay, so you have a mass which is 0.2 kg. So this is the M. So now you have M, you have U, you have V. Okay, we want to calculate impulse. So calculate the magnitude of impulse delivered to the ball by the wall. Okay, delivered to the ball by the wall. So what are we going to do? Now let's see. J equals to, the definition tells you that J equals to Ft. But according to impulse momentum theorem, okay, what we are going to do now is to apply impulse momentum theorem, where it tells us J is equals to delta P, which is equals to mv minus mu. That's why I told you before, impulse momentum theorem, it plays a very important role in our calculation. Because questions, quite often it won't give you the informations, okay, based on the definition. Right. You need to apply impulse momentum theorem in order to calculate the informations needed in order to answer the question. So for instance, this question is asking for impulse. Now impulse, the definition is J equals to Ft. But then we cannot use this equation because we don't have information about the force. Therefore, what are we going to do? We are going to calculate the J by using mv minus mu, by using impulse momentum theorem, okay, which is J equals to delta P. So from here, we expand the equation and we get mv minus mu. And then it is equals to, now when it comes to calculation, again, you need to make sure to include the negative sign. So negative 70 minus 0.2, and then U is 100. Okay, if you calculate it correctly, you're going to get a negative value, negative 34 ns. But if you look at the question is asking for magnitude. Aha. So what does it mean by this magnitude? It means you need to rewrite your answer. You cannot leave it in negative form. If you leave it in negative form, then sometimes it can be considered as a wrong answer. All right, because sometimes exam, they want to see whether you understand the meaning of magnitude or not. So you rewrite it in sentence, 34 ns. Okay, 34 ns to the left. Then now you have a positive 34. So this one, it represents the magnitude. Okay, it represents the magnitude. So this is the impulse to the ball by the wall. Okay, to the ball by the wall. So does it make sense? Yes. Okay, now if the question asks you to calculate the impulse to the wall by the ball, then what are you going to do? So you recall the diagram that I gave you the other day. So the moment the ball hits the wall, okay, impulse from wall to ball is going to the left. Okay, this is J, wall to ball. Okay, if the question is asking for ball to wall, then what are you going to do? So you just calculate as usual. Okay, you calculate as usual, and then at the end, okay, the directions of J, ball to wall. Okay, so once you obtain the answer, right, then you can say J, ball to wall, is equals to negative J, wall to ball. All right. Therefore, it is negative 34, and you have a positive 34 ns. So it means the impulse is going to the left. Okay, so does it make sense? Yes, it is. Because you look at my diagram. Okay, you look at the diagram. So diagram, it shows you if you are going to look at the impulse of a ball on a wall, then it's going to the right hand side. Okay, so it depends on the question. You make sure you read the questions carefully. See whether the impulse is on the ball or on the wall. On the ball, then it's going to the left. On the wall, then it's going to the right. So for instance, this question is on the ball. Okay, it's on the ball. So on the ball, we are going to take the directions to the left. We are going to take the green color arrow. All right. So all these, they are keywords that you have to take notes when it comes to problem solving. Okay, you look at whether it's asking for magnitude or vector, and then you look at the question, see whether it wants the impulse on the ball or it wants the impulse on the wall. So ball and wall, they are acting on a opposite directions. They are pointing towards opposite direction. So which means if you calculate the vector, they are just going to have a opposite sign. Okay, but when it comes to magnitude, you don't have to worry. Okay, now sometimes if you are unsure whether the question, okay, is asking for the impulse of the ball or impulse on the wall, and question is asking for magnitude, then you can actually rewrite the answer. Okay, I'm just going to change the final answer a bit. So you don't mention the direction. Okay, you say the magnitude. Okay, the magnitude of impulse is 34 ns. Then you don't mention the direction. Why? Because magnitude. Magnitude is very simple. Magnitude just asking for direction. Therefore, you give it a positive value without telling it whether it's going to the left or going to the right. Okay? So if you have a questions that involve magnitude and you're unsure which impulse that the question is asking for, then this is the, what I would say, cheating lah. Kita tipu sikit-sikit. Okay, this is how you write your answer. The magnitude of impulse is 34 Newton second. Then full stop. Okay, you stop at that. So you don't proceed to the direction because you're unsure which one is asking for. And the question doesn't ask for the direction. All right. So this is questions A. So questions A, the things that I want to show you, first thing is what does it mean by magnitude? The second thing, how to determine which impulse to use. All right. So you look at the question, see whether the impulse is acting on the object or it is acting on the wall. If it is acting on the object, then you have to draw the vector from wall to object. So which means it's to the left. Okay. If it is acting on the wall, then you draw the arrow from object to the wall. So it is going to the right. All right. So questions B. If the ball in contact with the wall for 10 ms, now this 10 and ms, because m and s, they are stick together, so it means 10 millisecond. So time is equals to 10 millisecond, which is equals to 10 times 10 to the power of negative 3 second. All right, so this is another very common sin mistake in the exam, where students say, I have 10 meters second. What does it mean by 10 meters second? I also don't know. All right, so 10 ms. So how do we know whether m represent prefix or vector? You look at whether there is a space between these two characters. Let's go back to questions 5, the main question. If you look at the main question, this ms -1, there is a space between m and s. Then in this case, we know this m represent meter. If you go to questions B, now m and s, there's no space in between them. In this case, this m represent milli. Okay, this m represent milli. So determines the magnitude of the average force exerted by the wall on the ball. Okay, exerted by the wall on the ball. So what are you going to do again? Now let's start from J equals to Ft. Okay, J equals to Ft, and then J is negative value. So negative 34 equals to F, and then 10 times 10 to the power of negative 3. And I have a force which is equal to negative 3,400 Newton. Again, question is asking for magnitude. Okay, question is asking for magnitude. Therefore, you rewrite it. The magnitude of the force, okay, of an average force is 3,400 Newton. Okay, 3,400 Newton. All right. So that is a complete questions 5 for you. So again, I give you a, now it's 8:41. I give you until 8:45, 4 minutes to write it down. Okay, especially how to determine the direction. Alright, diagram, part diagram dan part warna hitam ini penting. So write it down. So I give you 4 minutes to take notes. Write it in your own words. Write it in the way that you can understand. If you do revisions, when you do revision. Okay, jangan ikut apa yang saya tulis. Kamu tulis dengan cara Anda sendiri yang Anda boleh faham. Itu adalah cara belajar. So if you have any questions, you may ask or you may post in the chat box.
Madam,
Yes?
I don't really understand the part J ball to wall and then equals to negative J wall to ball.
Because of the direction. If you look at the diagram, one is going to the left, one is going to the right. And when you have a two vector, they have the same value. Now, these two objects, wall and ball, they are in contact. It means that the impulse, it doesn't matter whether it's the force hitting on the ball or the force from ball hitting on the wall. Now, because these two objects are in contact, therefore they must have the same value. The only difference between it is that the direction is opposite. It's basically something like your Newton's third law. Now you have something that is equals in magnitude but opposite in direction. How do I know that they are equals in magnitude? Okay, it is so it is because now these two objects, they are sticking to each other. Okay, they have a part where they are in contact with each other, which is here. All right, so now this is a case. This case is just like if you push a wall. Okay, now let's say now you have a wall, and then this is you. Okay, so you push the wall. Wait, your hand is too long. Okay. So you push the wall. Okay, so this is your hand, your palm, and then this is you. Okay, when you push the wall, what happened? Now, if you push the wall with 10 Newton of force, according to Newton's third law, this wall actually is pushing you back. Okay, it pushes you back with the same amount of force. Just that now both of you are not moving. Okay, so the idea is same here. When these two objects, they are in contact with each other, the impulse, actually they are the same. Why? Because impulse is about the force. The force over a period of time, okay? The force times time. So you want to see the impact. So the same impact, okay? If you causes 10 Newton seconds on the wall, then at the same time, the wall will exert the same amounts of impulse back to the object.
Will it be negative or positive?
Huh?
From if the wall would exert the same amount of force, will
opposite
it be
direction.
So negative.
Yes, in our case, it's negative. It depends on our diagram, actually. Sometimes, if the diagram gives you like this, okay, if you have a diagram, it tells you your ball is heading from the left, and then it bounces off to the right. So in this case, what happened is that now I still have the ball, okay, when it is in contact with the wall, the impulse from ball on the wall, okay, is going to the left. Okay, now this is from ball to wall. Okay, so this is J on wall. J on wall. So J on wall is now to the left. So if the question is asking for the J on ball, okay, then it will be going to the right hand side. So the green color arrow is from wall to ball. Okay, the impact exerted on the ball from wall. So from wall to ball. So this is
So
our J on ball. So in this case, our J on ball is positive.
okay,
Right?
yeah, clear. Thank you.
All right. Okay, so any other questions? Saya ada message. Okay, next. Next is questions number 6. All right. A force of 500 Newton is applied to a 1,200 kg truck for 5 seconds. What is the change in velocity? Now, if you look at this question, what is the things that it wants? It wants a change in velocity. Now, what does it mean by change in velocity? Well, it's not asking for initial, it's not asking for final, it is actually asking for delta V. Okay, means final minus initial. Now, again, if you look at the questions, well, it's asking for impulse curve or momentum. We don't know, right? Well, actually, it's impulse momentum theorem. So how do I know? Let's write down the information. So force is equals to 500 Newton. And then we have mass equals to 1,200 kg. And then we have t equals to 5 seconds. Question asking for delta V. So in this case, I have a J equals to delta P. That is my impulse momentum theorem. Impulse is Ft. And then momentum, well, momentum we know is mv minus mu, right? So if you, okay, let's see, delta P is equals to mv minus mu. So if you factorize the m out, it is v minus u. And it is actually m delta v. Okay, m delta v. So you want to test whether you understand this part or not. So I have Ft equals to m delta v. And delta v is the things that I want to find right now. So delta v is equals to Ft divided by m. Okay, divided by m. Yeah. Wait, yeah, the pen is acting up again. Yeah. Okay. So over m. All right, therefore it is equals to 2.08 ms negative 1. Now, of course, you have to show the substitution. Okay, you have to show the substitution because it worth 1 mark. Okay, just here, I'm just going to save time. I'm not going to write everything for you. So I showed you the method. You write down in a complete form. All right, you write it down in a complete form. So I give you 1 minute to write it down. Okay, especially this box. So how to obtain delta V? Delta V actually is coming from V minus U, okay, in your delta P equations, in the equations of delta P. Okay. All right, next questions. Okay, next question is wait, first. Okay, yeah. So next questions, again, if you look at the diagram, it is a two-dimensional question. Okay, it is a two-dimensional questions. So how are you going to solve it then? Again, you look at the diagram. So a tennis ball of mass m is equals to 0.06 kg. Okay, and a speed of v equals to 28 meter per second strikes a wall at an angle 45 degree, and it rebounds at the same speed as shown in the figures below. So calculate the impulse given by the walls. Excuse me. So how are we going to calculate it? So let's see. Right, you're going to the so now you have a force and then you have impulse. Okay, what are we going to calculate? We want to calculate the impulse given by the force. So we want to calculate the x component of the impulse. Okay, jx. So that is the things that we want. So how are we going to solve it? Wait, yeah. Okay, you try it first. I need to restart the document because it keeps hanging. Okay, you do it first. I restart the job. Okay, you try it first, yeah. So here got some technical issue. Okay. I think it should be fine now. All right. So a tennis ball of mass, which is equals to 0.6 kg and a speed of v equals to 28 meter per second, strikes the wall at an angle 45 degree at a 45-degree angles and rebounds with the same speed. So what do we have right now? Okay, so this is a, okay, I'm just going to redraw it. So what do I have right now? I have a wall, right? And then given it is 45 degree from the wall as shown in the figure, calculate the impulse given by the wall. So impulse given by the wall, the things that we want to calculate actually is along the x component, all right? Because when it hits the object, the effect from the wall, okay, the effect from the wall is 45 degree, okay? So what are we going to do right now is that we need to calculate J equals to change in momentum. Okay, change in momentum. And then, what are we going to do? Because we just want the x component, therefore J equals to mvx minus mux. Okay, so initially my v, okay, I'm going to take it as a positive v. Okay, wait, my u is a positive u. Okay, we assume it's positive, and then when it rebounds, then we take a negative value. So what are we going to do? Okay, so m v is a negative, so negative 28 cos 45 degree. Okay, cos 45 degree, and then minus m, okay, which is 28 now, cos 45 degree. Okay, because you take the x component, you resolve it, you take the x component only. So which is then equals to, okay, I forgot to put in the values for m. So given m is 0.06 kg, so you have a 0.06, and then here also 0.06. Therefore, the final answer is negative 2.4 kgm as negative 1. This is the impulse given by the wall. All right, this is the impulse given by the wall. So you take the impulse along the x component. So along the x component, what do we have? We have two vectors. Okay, we have two vectors. So if you rewrite it in a coordinate form, actually this is the vector that we're going to have. So this is y component, this is x component. So this is your u, and then this is your v. All right, so when you resolve it, because we want the x component only, so this is ux, and this is your vx. Okay, therefore, when we resolve it, v is a negative value because it's heading to the left, and your u is a positive value. All right, so we take the line that is perpendicular to the wall. So that is the impulse. Okay, impulse given by the wall on the ball. So it's the J on ball. So J on ball, according to the diagram, is going to the left. Therefore, I have a negative value here. So it makes sense. All right, it makes sense. Okay, so you can write it down. I give you 2 minutes to write it down before we proceed to the next exercises.
Madam,
Yes?
how to know the direction of the impulse?
The directions of the impulse, well, now you want the directions of the impulse on the ball. So you try to imagine at the moment it hits the wall. Okay, the moment it hits the wall, what happened? So we want the impulse on the ball. So the directions, you draw it from wall to ball. Okay, because it's given by the wall on ball. Actually, there is a hidden terms. So you need to understand the phrase. So given by wall on ball, then the direction is from the wall to the ball. All right. So in this case, we take the directions going to the left. All right. We take the direction that is perpendicular to the wall. Is that okay?
Then how to transfer it on the um graph.
Huh?
How to transfer the impulse daripada gambar rajah tu kepada graph.
Oh, dari gambar raja to the graph. You look at the directions of the arrow. Now, if you remember what I told you in the chapter 1, I told you vector must be coming out from the diagram. It cannot going into the diagram. If you look at this diagram, initially, this is the directions of the object. It's pointing towards the ball. So we take the positions where they hit each other, they are in contact as our origin. So you have you going into the origin, cannot write. So you extrapolate, let it come out from the other direction. That's why I have the directions here. Okay, so you take the blue color ball as the origin. Now you have a vector going into the origin. What are you going to do? You let it come out from the other side. So is that clear?
Okay, madam.
Alright. Kamu kena ingat dia punya vector mesti keluar dari origin. Dia tak boleh masuk origin. Kalau dia masuk origin, apa yang kamu kena buat? Kamu biar dia keluar di arah bertentangan. Okay, so kalau kamu pindah vector ini dari gambar raja ini ke sini, actually is located here. But we don't want the vector that is pointing towards origin. So what I did, I just let it come out from the other side. Okay. All right, next. Okay. Next part is a graph. Okay, next part is a graph. So how are we going to solve it? Again, you need to recall what is the graph that we have in this chapter. In previous chapter, now let's do a quick revision, right? So in previous chapter, we have ST graph. Okay, we have ST graph. Where ST graph, the information that we have is the gradient. So gradient of ST graph, it represents velocity. And then in previous chapter, again, we have VT graph. So gradient of VT graph, it represents acceleration. Okay, and then area under VT graph. Okay, area under VT graph, it is your displacement or distance. And then we have AT graph. Okay, AT graph, actually we don't extract any information from it. Okay, but you can actually calculate the velocity based on the area. All right, but the question, so I don't think it's in our syllabus, so that one we ignore it first. So in this chapter, what do we have? We have a FT graph. Okay, we have FT graph. So FT graph, what is the information that we have? We have area under the graph. Okay, area under FT graph, that is equals to our impulse. So far we have learned 4 types of graph, and you have to know the functions of every graph. Okay, which part of a gradient, okay, which part of the graph represent which information. That is the things that we need to memorize. Okay, all these things, it won't be given in the exam, and all these things, you need to write it, you need to study in your solution, because it is part of the concept mark. Okay, it is considered as concept. So when it comes to concept, usually you will be awarded 1 marks, K1, if you write it down correctly at the correct place. Okay, K1 marker concept 1 marker. That is the meanings of K1. So usually if you write down all these terms, okay, gradients equals to velocity, gradient equals to accelerations, area equals to a displacement, area equals to an impulse, then usually you will get 1 mark. All right, because it means you understand the concept. So now we have a chapter 3. Chapter 3, if you look at the graph, we have F. Okay, we have F again. F against T graph. Okay, so when it comes to F against T graph, then we know area under the graph represents the impulse. Now let's see, is that the things that we want? So apply force against time graph of an object is given as shown in figure. Find the impulse of the object between 0 until 10 seconds. So basically the whole journey. Okay, basically the whole journey. So what are we going to do? First thing, question asking for impulse. You have to tell the reader, how do you know where is the impulse, how to calculate the impulse. Therefore, state area under FT graph. It is equals to impulse. So from here, okay, if you got this statement correct, then usually you will get 1 marks. Okay, you will get the marks for concept K1. And then you calculate it. So impulse is then equals to, now area under the graph. So this whole thing now is a shape of trapezium. So 1/2, and then I have the base is 10 plus the upper line. Upper line is 6 minus 2. 6 minus 2. Okay, and then times with the height, which is 20. So times 20. All right. Wait, I put too many bracket already. How many bracket in my solution? Okay, I don't need this one. All right, so this is how you calculate it. So once you got this area correct, usually you will get another marks for the substitution. Okay, you will get another mark for G1 because you know how to apply the equations. And then the final answer, 140 kgms -1. So another 1 mark. So when it comes to graph question, it is very important to write down this statement. All right, it is very important to write down this statement. So this statement itself will give you 1 mark. So even if you got the answer wrong, okay, if you don't know how to calculate the trapezium, you got the trapezium, the equations of trapezium wrong, you can still get 1 mark for the concept. Okay, so 1 mark for concept, 1 mark for substitution, and 1 mark for the answer with unique. Okay, 1 mark for the answer with unique. So this is how you solve it. All right, so make sure to write it down in a complete form. So 1 minute for you to write it down. So if you are done, you try questions 2. Okay, if you are done, you try questions 2. Questions 2 is a bit tricky. All right, questions 2 is a bit tricky, but I want you to try it first. So I give you 2 minutes to try questions 2 before I discuss it. Before I discuss it with you. All right. So I give you 2 minutes to try it. Try questions A. See whether you can get correct answer or not. Okay, cuba ya, jangan tak cuba. Kalau tak cuba, maka anda tak tahu mana kesilapan anda. Okay. So before we start, I'm not sure whether you notice or not. If you look at the graph, okay, if you look at the graph, the unit is no longer Newton and second. The units given is Kn and ms. So this is usually the mistake that students they will make in the exam, right? Because they forgot about the unit, the prefix. So how are you going to solve these questions? Again, questions 1, the impulse delivered to the ball. So an estimated force time curve for a tennis ball of mass 60 grams struck by a racket is shown in the figure below. So calculate the impulse. Impulse is area under the graph. Okay, so area under the graph is equals to impulse. So impulse, now you have a triangle. This is no longer trapezium. So 1 over 2 times the base. Base is 1.8 minus 0.2. So 1.8 minus 0.2 times 10 to the power of negative 3 because millisecond, right? And then times the height. So the height is 18 times 10 to the power of 3 because it's kilonewton. So times 10 to the power of 3, which is then equals to 14.4 ns. All right. So this is the part where students always forgot to write in their solution. So times 10 to the power of negative 3 for the base, which is the time, and then times 10 to the power of 3 for the force, which is the height of the triangle. So again, this is a 3 marks questions. All right, 3 marks questions. And then questions B. Okay, questions B, calculate the speed after it is being struck. Now, speed after being struck, it is asking for final velocity, V. So assuming the ball is being served so that it's nearly at rest initially. So at rest initially, again, the hidden information that we have is U equals to 0 and S negative 1. So now you want to calculate V, and then based on the questions 1, we have impulse. So J equals to mv minus mu. Again, our impulse momentum theorem. So impulse we have 14.4, and then it is equals to m. Okay, m given is what? Given 60 gram. 60 gram, remember to change into kg. All right, so 60 gram, 60 times 10 to the power of negative 3. Okay, 60 grams to kg, and then times with the velocity. So initially it is at rest, so U is at rest. So what are you going to calculate is just V. So V, all right, and then minus 0. So rearrange the equation. V is equals to 240 meter per second. All right, 240 meter per second. So that is how you answer questions B. Okay.
Madam,
Yes?
I have a question. Why 18 times 10 to the power of 3?
Why 80? Where is my 80? Why got 80?
18
Oh,
times 10 to the
18.
power of 3. Yeah.
Well, it is because of the unit. You look at the axis, the y-axis. Y-axis km, kilonewton. Okay, so in physics, you have to be extra careful with the unit.
Okay.
All right. So that is the questions 3 and questions 2. So if you're done, then you try questions 3 first. Okay, questions 3 is very similar. It's very similar to this question. Okay, questions 3. Questions 3, according to the questions, now you have 2 people, so Paul and Nick. Wait, yeah. 3 objects, not 2. So Paul and Nick push a fuse broken down car down the road. At times t equals to 0, they push with a force of 1000 Newton. They reduce their force gradually to 500 Newton at times t equals to 5 seconds, and then continue pushing with a constant force for another 5, which means the final time is 10 seconds. So if the car is 1,500 kg and it starts from the rest, what is the final velocity at the end of 10 seconds? So this question seems very long, but actually it's just asking for final velocity based on the graph given. So graph given is F against T. So F against T means that area under the graph, area under FT graph, again, it is our impulse. So this question, the only difference between this question and previous question, it guides you. It gives you questions part A to calculate impulse, and then part B, you use the impulse to calculate the final velocity. This question, it combines both into one. It doesn't mention impulse. You yourself have to know that you need impulse. All right, and this is what we call hot question in your exam. You need to think, what is the information needed before you can calculate final velocity? Right? So area under FT graph is impulse, and then you calculate the area. Now it's up to you whether you want to calculate into 3 parts, you want to split into 3 parts, or you want to split into 2 parts. All right, so this part I leave it to you. Okay, I leave it to you. So the impulse, if you calculate it correctly, then you are going to get impulse. Impulse equals to 6250 ns negative 1. All right, so area is up to you. You want to split into a triangle and then a rectangles, or you want to split into trapezium rectangle. It is totally up to you. Both are accepted in your exam. So once you have impulse, you can then calculate the final velocity. So again, J equals to mv minus mu. We have a mu equals to 0. Okay, because of what? Because u equals to 0. Therefore, J is 6250 equals to, your M is 1,500 kg times with the V. Rearrange the equation, V equals to 4.17 ms negative 1. Okay, V equals to 4.17 ms negative 1. So this question is totally same as the previous questions, the way to solve it. The only difference is that you need to think. You need to know that you need impulse in order to solve this question. And this is the so-called hot questions in the exam. All right, in your exam, there will be a few hot questions. So if you have a hot question, then that is the meaning. This is what it means. All right, there is no guidance. You yourself have to know. You need to calculate impulse first in order to apply impulse momentum theorem, in order to find the final velocity. Okay, so 1 minute for you to complete this question. If you are done, then you can try questions 4.
Madam,
Yes?
how to know why the initial velocity is 0?
Hey, did you pay attention? I even circle the reason for you. You see? The car start from rest. So if it start from rest, then initial is definitely 0. Okay, the key words is the rest.
Thank you, madam.
All right. So questions 4, I will leave it to you. Okay, the idea to solve it is exactly the same as questions 2 and questions 3. All right, so what am I going to do now? Okay, I'm going to proceed to 3.2. Okay, I'm going to proceed to exercise 3. So these questions, you tried it by yourself. The only difference is that now you have a negative area. Okay, so think about it. How are you going to solve it when you have a negative area? So if negative area means that you just subtract it. Okay, minus there. So you have positive area and then you have negative area. So positive minus the area. Okay, the positive, the upper side, the upper area minus the lowest area. So that one, I leave it to you. So this table, I will skip it. Okay, I will just let you complete the blank. Okay, so we are going to do fill in the blank only. So So the equations that you need to put in your notes is the here. Okay, for elastic collision, the momentum is always conserved. So total P initial equals to total P final. Right? And then when it comes to kinetic energy, so like I told you last week, how do we differentiate? Which one is elastic collision? Which one is inelastic collision? Elastic collision, kinetic energy. Okay, summations, kinetic energy, we use symbol K. Initial is equals to summations K final. So no loss of energy. But if it is inelastic, then initial K is not equals to final K. All right, so that is the difference between elastic and inelastic. So it doesn't mean that the objects stick together. Okay, sometimes they are not stick together. So the kinetic energy is not conserved in an inelastic collision. Why? Because some of it is being transformed into sound and heat. And most of the time, in reality, we have inelastic collision. Elastic collisions can only occur in an ideal situation where we assume there's no frictional force, there's no air resistance, and so on. So it can only exist in ideal situation, in theory. So caution, now this is what I told you last week in the lecture. Not all the inelastic collisions are sticking together. Okay, if they are stick together, then that one we call it perfectly inelastic collision. But if they are not stick together, then you need to check their kinetic energy. Okay, so this one we discussed already last week. I don't want to waste time already. So let's proceed to exercise 3. So exercise 3, now we are going to use conservations of momentum. We are going to apply the principle of conservation momentum to solve questions. So figure below shows object A of mass 200 gram. So I have MA equals to 200 gram. Now this is what I like to do. I like to label everything when I solve it. So collides head on. Now, sometimes students, they will ask me, do I have to change this M into kg? Because when it comes to a impulse J, we need to convert into kg. But when it comes to the law of conservation, okay, when it comes to law of conservation, you don't have to change the unit. Why? Because the left-hand side and the right-hand side, they will cancel with each other. So as long as left-hand side and right-hand side, both of them, they have same unit, then you don't have to change it into SI unit, unless the question asks you to state in SI unit. Okay, but this one is only for conservation, law of conservation. Conservations of energy, conservations of momentum, conservations of charge, all the conservation law, the law of conservation, you don't have to change it into SI unit unless the questions ask you to do so. All right, so in these questions, okay, you have MA equals to 200 gram. You can leave it in gram, it doesn't matter. But if you want to change it in kg, of course you can. There's nothing wrong. Okay, there's nothing wrong to change everything into SI unit. Just that I tell you in advance, okay, it is not a must. Right, it is not a must, because sometimes students, they get confused. They say, okay, miss, I look at the books say I don't need to change it. So when do I have to change the unit into SI unit? I got so confused after I look at all the revision books. Now that is the reason. Law of conservation, convert to unit, convert to SI unit is not a must. Okay, because you have a left hand side and right hand side. As long as both sides they have same unit, then you can leave it. Okay, you can leave it in gram. But if you are going to calculate J, for example, J equals to FT, where you have or J equals to MV minus MU, where you have M only on one side, then this one must be in SI unit. Okay, this one must be in SI unit. But if you look at the conservations where you have M on both, okay, you have both of them, left and right. As long as left and right, they have same unit, then that is fine. Okay, so that is how we know whether we need to do unit conversions or not. So in these questions, because you're looking at the conservations of momentum, therefore you can leave it in gram. So figure below shows object A, 200 gram collides head on. So head on means two objects must be coming from the opposite direction with object B of mass. So I have MB which is equals to 100 gram. So this diagram, they give you the magnitude. To be more precise, UB and a UA. So if you look at the diagram, UA is going to the left. So UA should be a negative value. Okay, UA should be a negative value according to the diagram because it's going to the left. All right. So this is a negative 6 meters per second. So after collision, B moved with a speed 2 meters per second to the left. Right, so we have two situations. So what am I going to do now? I'm going to do one more diagram. So this is my B, this is my A. So after collision, my B is going to the left with a final velocity VB equals to negative 2 meters per second. So I still have a same MB, which is 100 gram, same MA, which is 200 gram. But now I don't know what is the velocity. So VA is an unknown. Okay, so calculate the final velocity. So determine the velocity of A after collision. So this is before. So usually I like to sketch a diagram for before collision and then a diagram for after collision. Okay. After collision. So one for before, one for after. Then I can proceed to my calculation. Okay, I can proceed to calculation. So let's start our calculation. So now this is a collisions between two objects. When it comes to collisions, then we know we are going to use conservations of momentum. So let's begin with this delta plus summations P initial equals to summations P final. So this is a mass. Okay, this is your concept 1, K1. So always state it in your solution. Okay, always state the law of conservations in your solution. So then you calculate. Okay, you substitute MA UA plus MB UB equals to MA VA plus MB VB in your solution. All right. And next, what are we going to do? We're going to solve it. We are going to substitute the value into the equations. So you have MA equals to 200 gram. So MA 200 gram. UA must be a negative value. So negative 6. This is where students always got it wrong in the exam. Okay, so negative 6 plus 100 and then 3, which is equals to, now this is what this is still 200 MA, and then VA is the unknown, you leave it as unknown, plus 100 gram, and then my VB. Okay, my VB, which is a negative 2. So negative 2. All right. So remember to put a negative here. So in this case, what do you have? You have a VA equals to negative 3.5 ms negative 1. Okay, negative 3.5 ms negative 1. So after collisions, you have a negative 3.5. All right. So next, is this collision elastic or inelastic? So you just calculate. Okay, this one I'll leave it to you. You calculate your kinetic energy. So total kinetic energy before and total kinetic energy after. All right, and then you make a conclusions whether the collision is elastic or inelastic. You have to show. All right, so you're going to calculate total K initial, which is 1 over 2 MAUA square plus 1 over 2 MB UB square. And then you calculate summations K final 1 over 2 MA VA square plus 1 over 2 MB VB square. All right, you calculate and then compare the value. See whether it's elastic or inelastic. All right, so this one I'll leave it to you. Kamu sendiri cuba. So I give you 5 minutes to try it. All right, I give you 5 minutes to calculate the kinetic energy. And then after 5 minutes, you post in the chat box. Tell me whether it is elastic or inelastic. Okay, bagi kamu sendiri cuba kira. Okay, kalau tak cuba, anda tak akan ingat. Tak ada lagi kah yang dapat jawapan? Elastic or inelastic? Post it in the chat box. I want to see you guys try it or not. Okay, so good. A lot of you got the answer already. It is inelastic collisions. So that is how we prove it. All right, good. So you calculate it, you calculate the value, and then you make a conclusion. Since delta k in delta again, summations k initial is not equal to summations k final, therefore the collision, the collision is is inelastic. Okay, the collision is inelastic. So this is how you answer it. All right, so this question actually is worth a lot of marks, starting from a calculations of V, and then you prove it. Okay, you show the calculations, and then you came to conclusions. Now, when you answer the questions, remember to show the last two sentences. Okay, this two is very important. So usually this one it got 1 marks, and then this one it got 1 marks. This is the reason. Okay, this is the reason. This is your justification. All right, we say justification. And then this one is the answer. So justification, usually it worth 1 marks in explanation question. So when the question asks you to justify something, this is how you justified it. Okay, you show it by using equation. You show it by using calculation. Right? So usually this last two statement already got the 2 marks, and then try to imagine all the calculation. So you have this one K1, and then the substitution, and then your answer, and then all this showing maybe is another 1 marks. All right, either 1 or 2 marks. So let's see 1, 2, 3, 4, 5, 6, at least 6 marks for these questions if it comes out in the exam. All right, if it comes in exam. So exercise 3 done. Questions 1. So now questions 2. Okay, now let's look at questions 2. Questions 2. All right. So questions 2. A marksman holds a rifle. Okay, rifle is a gun of a mass MR is equals to 3 kg loosely in his hand. So so as to let it recoil freely when fired. Okay, so dia bukan pegang. Okay, it just hold loosely. Okay, hold loosely. So tak pegang dengan kuat. So that the guns, the rifles can recoil. Okay, recoil means it moves backwards when it fires. So it fires a bullet of mass M equals to 5 gram. So now this is the part that you have to take note. Just now I say you don't have to convert unit, provided if they are in the same unit. Now if you look at this question, you have one in terms of kg, another one in terms of gram. So you have to make sure both of them, they are in the same unit when you solve it. Okay, so it fires the bullet of the mass MB equals to 5 gram horizontally with an initial velocity 300 meter per second. So now you have a rifle gun. Okay, you have a rifle gun. Well, my drawing. Okay, as long as you can understand, then that's fine. So initially, the bullet's staying inside it. Okay, so this is the bullet. So initially, both bullet and the gun, they are not moving. Okay, so before fired, U is equals to 0. Okay, U equals to 0 meter per second before you fire the bullet. So after you fire the bullet, okay, this is the gun. And then what happened? It recoil. Recoil means it moves backwards. And then the bullet's going towards the other direction. Okay, it goes towards the other direction. So with a velocity, so your V bullet is equals to 300 meter per second. So now your V rifle is unknown. So how are we going to solve this question? So if you look at this question, this is an examples of explosion. Okay, explosion, which means initially both objects, they are not moving. So initially, okay, again, I'm going to write it as a P initial equals to summations P final. So initial, I have 0 because it's a case of explosion equals to MR VR plus M bullet plus V bullet plus bullet times V bullet. Okay, so M bullet times V bullet. So 0 equals to, now my rifle is 3 kg, VR is unknown, plus now 5 gram bullet. So it's 5 times 10 to the power of negative 3. You need to make sure both M, they have same unit. Okay, both of them, they are in terms of kg. So now they're in kg. So times with VB, which is 300 meter per second. Okay, then you're going to get V rifle equals to negative 0.5 ms negative 1. Okay, M. Okay, ms negative 1. So this is the question's aim. Calculate the recoil velocity, which is the final velocity of the rifle. And then question asking for final momentum. So how are we going to find the final momentum of the system? Now, when it says of the system, means it includes all objects. Okay, it includes all objects. So in this case, we have 2 objects. which is the riffles and the bullet. So you have to calculate the total momentum for both of them. All right. So the total momentum, okay, summations P final. Now, actually, you don't even have to calculate. Why? Because if you understand, P final is equals to P initial, and our summations P initial is 0. Therefore, it is equals to 0. Now, of course, for students who don't know, who might have forgotten about this, of course, you can do the calculation. Okay, you can proceed to the calculation. MR and then a VR equals to MB plus MB VB. So eventually, you are going to get 0 as well. Okay, you're going to get 0 as well. So 0 kg ms negative 1. 0 kg ms negative 1. All right, so you have two methods. So this one, if you understand, okay, you understand the summations P just now is already 0, therefore the final momentum is 0. If you don't understand, okay, if you forgot, sometimes we did, okay, sometimes it's not that you don't understand, sometimes it's because you forgot, you can use this method, then you proceed to the calculation, that is fine as well. All right, you're still going to get a 0 because MR VR plus MB VB is equals to 0 based on our calculation just now. Okay, so either one. Kamu boleh pilih mana-mana. Okay, kamu boleh guna yang mana-mana satu. Okay, so next. Okay, so ini okay kan soalan ini. So next one. Questions 3. Questions 3. An object P. An object P of mass 4 kg. Okay, so I have now MP equals to 4 kg. Move with a velocity 4 meter per second. So MP equals to 4 meter per second. Collides with another object Q. So MQ equals to 2 kg. And then moving with a velocity 3 meter per second towards it. So now you have a VQ, but VQ now I know is negative 3 meter per second because it's moving towards P. Okay, it's moving towards P. So both of them, they are moving towards each other. They are moving in the opposite direction. So this is before collision. So object P, and this is object Q. Okay, object P and object Q. So I have the information already. Now, actually, the more precise symbol should be U, before collision. Okay, so I have a UP, and then I have a UQ. Right? So this is before collision. So determines the total momentum before collision. So summations P initial equals to MP UP plus MQ UQ. Okay, which is then equals to 4 plus 2 negative 3. So the answer is 16 minus 6, 10 kg ms negative 1. Right, 10 kg ms negative 1. So make sure to put a bit of space between all these unit. Yeah, don't follow the unit in the books. Okay, because there's a typo when they mix the book. This is incorrect. Okay, this is incorrect. Make sure there's a space between kg and m, between m and s. Otherwise, it becomes millisecond. So if a P immediately stop, so what does it mean? It means your VP is equals to 0 because it's stopped. All right, so calculate the final velocity of Q. So again, what happens? So again, we are going to use summations P initial equals to summations P final. Initial we have already, okay, so you don't have to calculate it anymore. So 10 equals to final, according to the question, it tells you now VP stop. So VP, MP, VP, okay, later you can replace it with 0 plus MQ, VQ. So 10 equals to 0 plus M for the Q is 2 kg VQ. Okay, and then therefore VQ is equals to positive 5. 5 meter per second. Remember, velocity is a vector. Vector, you need to state its direction. So to the right. Okay, to the right. If the question asks you to calculate speed, then you don't have to state the direction. But if the questions ask you to calculate velocity, then you need to state the direction. So it is 5 meter per second to the right. Okay, so the questions here, actually it shows you a shortcut. Okay, a shortcut. So since you calculate total initial momentum before collisions, okay, total momentum before collisions in the questions A, straight away you can apply it in the questions B. But of course, if you want to calculate it again, okay, go ahead. Tak ada masalah. Okay, sebab kadang-kadang pelajar dia takut. Okay, kalau buat begini saya confused. Okay lah, kalau confused sangat, then you can continue with MP UP plus MQ UQ equals to MP VP plus MQ VQ. Then you repeat the calculations again. Okay, it doesn't mean that you're wrong. That's still correct. Alright, saya cuma tunjuk anda sikit shortcut to save time. Okay, now question C. If two objects stick together after collisions, then calculate the final velocity. So basically, you just repeat the same thing. Okay, so total initial P, total final P. Initial, I have 10, and then final, since it says stick together, then what am I going to do? I'm going to put a bracket here, MP plus MQ. Both of them, they are moving with the same speed called V. Okay, so now you don't have VP, you don't have VQ. Remember, when it stick together, you have only one V. So 10 equals to, first object is a 4 kg, 4 plus 2. Okay, 4 plus 2, V. So V equals to 1.7 ms negative 1. So that is how you calculate it. Okay, so that is how you calculate it. So again, this is a positive value. So remember to put a bracket, say it is to the right. Right, so again, because the question is asking for vector, velocity. Okay, velocity. So velocity is vector. Vector, you need to state its direction. Okay, so that is question number 3. See, I think we can finish one more questions and then we leave the other 2 questions for the next slot. Yeah, next question is still 1D. Camp. All right, so let's proceed to the next questions. Yeah, any questions? No, let's proceed to the next question. Questions 4. Questions 4, a bullet of a mass 50 gram traveling horizontally. It strikes a stationary. So now the keywords is a stationary, right? So what does it mean by stationary? Stationary means that it is not moving. Okay, not moving. So what does it mean by not moving? Not moving means that your U, okay, now is a wooden block. So UB equals to 0. Wait, you wooden block, and then you have a bullet. Now I'm going to call it W. Okay, wooden block, because bullet already used B. So so I'm going to use UW, right? So W for wooden block, and then B for bullet. So W, okay, UW is a mass of 2 kg resting on a smooth. Okay, the reason why it tells you smooth horizontal surface, because it wants you to ignore frictional force. All right, the reasons why they mention smooth horizontal surface. So it carries a hidden meaning. Ignore frictional force. So means there's no energy loss due to friction. Okay, so the bullet, it gets stuck in the block. So what happened here is now you have a bullet. Okay, you have a bullet, and this bullet moves towards a wooden block. So this is initial case, initial situation, before collision. Okay, before collision. So after collision, okay, after collision, what happened is that now you still have this wooden block, but then the bullet is inside it. So what does it mean? This means this is actually a inelastic collision. Okay, and not just an inelastic collision, it is completely inelastic collision because two objects, they stick together after collision. Okay, this is one of the example where objects stick together after collision. So name and state the principle that can be applied to find the speed of the block and the bullet system after the bullet enters the block. So this is a very rare question, and it's actually a past year question where it asks you to state the name of the principle. So the principle of the conservation, okay, of conservation of linear momentum. Okay, of linear momentum. So this is actually one of the past year question. Okay, so you see, this is the type of the question that can comes out in the exam. It asks you to name or state the principle. So now this type of questions, if it comes out in the exam, it will comes out in the UPS. All right, because it's a state. So now name and state is a UPS type question. So past year question, you have to state it, but now no longer have to do it. Okay, this is your objective question. So calculate the speed of the bullet and block system immediately after impact. So it's asking for final velocity. So what do we have? We have a bullet, M bullet, which is 50 gram. But now I want to change it into kg because wooden block is in kg. So 50 times 10 to the power of negative 3 kg. And then bullet is moving with an initial velocity 600 meter per second. And then my wooden block, MW, wooden block is 2 kg. And then UW equals 0. Okay, because initially it is stationary. Stationary means it is at rest. It is not moving. So next I'm going to calculate. Summations P initial equals to summations P final. Right, so what happens now? I have MB UB plus MW UW equals to, now because they stick together, therefore MB plus MW times V. So you need just one velocity, right? So initially, what do I have? I have a 50 times 10 to the power of negative 3 times 600 plus 0 equals to 2 plus 50 times 10 to the power of negative 3 times V. So rearrange equations, V equals to 14.63 ms negative 1. So this is the final answer, and this is how you solve it. So you have to be able to visualize the situations given. All right, so how to visualize? This is how you do it. Okay, this is how you do it. So a question C. Okay, question C, now we are going to go back to an impulse. So if the time of impact was 5 times 10 to the power of negative 4, calculate the force that the bullet exerts on the block during the impact. So how are we going to calculate? So we want to calculate force. Okay, we are given time. So obviously this is about impulse. So J equals to Ft. But then we don't have the information about J, right? But what we do have is the momentum. So we can use delta P. So Ft equals to delta P. So Ft is equals to mv minus mu. So the velocity, the final velocity of the bullet, okay, minus the initial velocity of the bullet. All right, so we have a Ft force. So the force of the bullet exit on the ball. Okay, so force I have unknown. Time is 5 times 10 to the power of negative 4 equals to, okay, my bullet is 50 times 10 to the power of negative 3. Final velocity is a 14.63 minus 50 times 10 to the power of negative 3 times, again, this one, your bullet initial is 600. All right, then you should get F equals to 5.85 times 10 to the power 4 Newton. Right? So you solve it and see whether you can get the correct answer or not. So this is how you solve the questions, right? This is how you solve the questions.
Madam,
Yes.
yesterday I asked you a question in Telegram to be discussed in Google Meet.
Oh, yes.
Yeah.
So let us finish this one first. Okay, we still have 5 minutes.
Okay.
All right, so this is how you solve it. The bullet exit on the block. This one you'll get a negative value. All right, this one you should get a negative value because this is the force on bullet. So to calculate the force on block, okay, force on block equals to negative force on bullet. Okay, so which is equals to 5.85 times 10 to the power 4 Newton. All right, so since you calculate with the speed of bullet, you're calculating the force acting on the bullet. Okay, so if you have to calculate the block, then actually you just now you can straight away use the velocity of the block. Then you can find out what is the force on the block. Okay, I just noticed the words on the block. Bukan on the bullet. Okay, now it's on the block. So this is the types of the questions where you have to be careful. So force on the block is equal to negative force on bullet. So based on the calculations, the things that we calculate is actually about bullet. So how do I know that it's about bullet? Because I use all of the informations for bullet. Okay, all the informations that I use in my calculations, they are all for bullet. So this all of this, okay, all this information, they are for bullet. Therefore, the force that you calculate, the pen got some problems today. Okay, so the informations that we calculate, F is actually for bullet. So if you want to calculate on the block, then you just add a negative sign. Okay, then this is your final answer. Okay, so next. Let me see. You guys have class after this, guys?
Yes, madam.
All right, then I will finish it quickly. So your friends asked me to calculate. Yeah, let me switch the screen. I'll finish it very quick. Okay, now when it comes to these questions, okay, how are you going to do it? An object is launched at an angle 25 degrees at an initial velocity, all right, at an initial velocity 42 meters per second from the roof of a building at a height of 50 meters per second. Determines the range. So actually the diagram is similar to the diagram in the questions 8, just that now you have something that is going up. Okay, let's see if I can draw. So I have an object. Okay, this is the height of the building. Now my object is going up and then it goes down. All right. Okay. So angles given is a 25 degree, and then initial velocity. So you have initial v, which is u equals to 42 ms negative 1. Calculate the maximum height. This one shouldn't be an issue for you from the ground. So you calculate. Okay, you let this a building acting as your h equals to 0 first, and then you calculate the maximum h. Okay, this is for questions 1. When will it reach maximum height? So you calculate the time taken to reach maximum height as well. Velocity when it strikes the ground. So now, when it comes to questions C and D, you can no longer use the information from questions A. Why? Because questions A, you are using the height of the building as h equals to 0. That is our assumption. When it comes to questions C and D, you need to form another table where we use this here as our final position. So if you use here as a final position, what should we put in the table? Okay, so okay, let us complete the table, then you guys may go. UVSAT. So U, you still have it. So 42 cos 25 degree, 42 sine 25 degree. V, okay, Vx still 42 cos 25 degree, Vy unknown. Okay, for Vy is the things that you want to calculate. Sx, Sx you want to calculate in questions D. So this is also an unknown. But Sy we do have it. You look at the initial and you look at the final position. Initial position is here. Final position is here. The height of the building is 50 meter. Therefore, you do have information about Sy, which is negative 50 meter, which indicate that it is located below the original position. A0, this is negative 9.81. So from here, you should have more than enough information to solve C and D. All right. C, you calculate the Vy, and then you calculate the resultant V. And then for questions D, you need the time. So try to think, how are you going to get time? If X component don't have time, it means you can get it from Y. All right. So that's it. You may leave the class now. All right. Don't be late to another class. Now you're late for 1 minute already. Go faster. You can go to another class.
Okay, thank you, madam.
All right.
Thank you, madam.
Thank you, madam.
Thank you, madam.